All right, we are going to run through a very, very short, simple section here today. And what we'll be looking at is area of a triangle. And to begin with, we're going to look at a few new formulas for finding the area of a triangle. So one of the things that you're probably familiar with, I imagine, is that if you just have a triangle, kind of like a right triangle. Let's start by looking at a right triangle. And let's say that you've got just a couple of sides here. Like you've got, let's say that this is 8 centimeters and say that this is 6 centimeters. Okay, one of the things that you've learned is that you find the area of a triangle by doing 1/2 the base times the height. And the reason it's half is because if you look at a rectangle, in this same situation, the area of the rectangle on here would just be length times width, or 8 times 6. Well, the area of the triangle, it would make sense, would just be half of that. Right, so that area would be 48/2, which would be 24 square centimeters, like that. So you've learned that the area of a triangle is 1/2 base times height, and the height of a triangle, for any triangle, you can compute what the height is. Now, if you had a triangle that was oriented more like this, where you had a base of, say, 7 centimeters or something like that, then the height is outside the triangle, so you could compute what that height is right there, and say if that height was 5 centimeters, then you would have the area of that triangle would be 1/2 times the base, 7 centimeters, times the height, 5 centimeters, like that. So you'd really have half of 35 centimeters, which would be 17.5 square centimeters is what you'd have there. So that's kind of the things that you've done in your past. We now can use trigonometry to utilize the side angle side case. So if you're given a side, an angle, and a side, you can use any of these 3 formulas to compute the area. Okay, so what I'm going to do is I'm going to construct a basic triangle here. And I'd have you just draw out some sort of a triangle, some sort of an oblique triangle, basically. So let's draw this out like this. And let's label the sides and angles like we're used to labeling these then. Okay, so what I'm going to do is I'm going to call this alpha. I'm going to call this beta, and I'm going to call that gamma. And of course, that's going to make this side A, side B, and side C. So what I want to do is I want to do a derivation of one of these formulas. Okay, so what I'm going to do is I'm going to drop down, straight down to the base, and this is going to formulate the height of that triangle. Right? Now, if you look at this particular triangle, if you did the sine of A, the sine is opposite over hypotenuse, and see, this is a right triangle right here that I'm looking at. So I could say the sine of alpha is equal to h over b. Then I could solve that equation for h by multiplying both sides by b. So I'd end up getting h equals b sine alpha. Now what I'm going to do is I'm going to take the formula that I'm familiar with for finding an area of a triangle, which is area equals 1/2 the base times the height. Well, in this particular diagram, the base is going to get replaced with C, and the height h is going to get replaced with b sine alpha. So if you do that, you'd end up with 1/2 the base, which is C, the height, which is b sine alpha, and then that would prove and kind of show you a derivation of that formula right there. So notice in this particular problem, I need to know these things. I need to know alpha, because that's in the formula. I need to know b and c. So that is the side angle side case, like that. So really, when you're doing these formulas, it just depends on what you're given. For this particular formula, you'd be looking at a triangle that looks like this. You'd have a side beta, you'd have alpha and gamma, like that, and you would have A here, and you would have C here. So if you wanted to find the area of that triangle, See, this formula has given the side and angle and side case, so all you'd have to do is just take 1/2 of the product of the sides times the sine of the angle in between. So it's probably best to learn this in words because it's easy. So if you have a side angle side case and you want to find the area, well, that area is equal to 1/2 the product of two sides times the angle in between. So that's the way I learned that in words. Okay, so I don't really even have to look up the formula. So if I have a side angle side given in my triangle, I just do for the area 1/2 product of the sides times the sine of the angle in between. All right, so I'm going to do this this problem here, and let's start just by drawing a triangle out of some sort. Doesn't have to be drawn to scale necessarily. Let's draw it out and let's find the area. Okay, so let's see. To begin with, okay, so I'm going to go ahead and let's get a triangle here drawn. I'm kind of having a little bit of trouble with my program here. Okay, so let's get a triangle drawn. Any type of oblique triangle will do. And let's label what we're given and see if we have the side angle side case. All right, so let's say that this is alpha, and alpha was given as 22.7 degrees. Let's say this is beta, and let's say that's gamma. So B was given as 12.0, and then C, opposite gamma, was given as 6.9. So indeed what you have is you have a side, then an angle, and a side. So when you do this formula, instead of looking the formulas up, just remember in words. You have a side angle side given in the triangle, so it's going to be 1/2 the product of the two sides times the sine of the angle in between those two sides. And then you can go directly to a calculator and compute that area. Okay, so when you're computing this on the calculator, again, you want to make sure you're in degree mode. So what I'm going to do is for 1/2, I'm just going to put in 0.5 times 12 times 6.9 times the sine of the angle in between, 22.7. And then that'll give the answer. The problem will round that off to, let's just round it to 16. So we're going to say the area is approximately 16 square units. So remember, area is always in square units. Okay, so that's all there is to it. Okay, it's very easy to compute that. Okay, go ahead and compute the next one. I'll let you guys go ahead and draw a triangle and compute number 3, so I'm going to pause this for just a minute. Okay, so let's see if we got this one computed. Again, I'm going to draw a triangle just so that I can see that I've got the side angle side case. Triangle does not have to be drawn to scale. You can label it as you wish, as long as you're consistent with the naming convention that we've learned. All right, so I'm going to go ahead and call this beta. Beta was given as 60.8 degrees. I'm going to call this alpha, and then the side opposite that, A, was given as 36.2. I'm going to call this gamma. So that would mean that C is equal to 45.7. That would be B. So again, you notice that I've given a side, angle, and a side. So this is the side angle side case. So we can compute the area as follows. We say the area is 1/2 the product of the two sides times the sine of the angle in between, 60.8. And then we can go directly to our calculator to do that. So I'm going to just put in 0.5 times 45.7 times 36.2, and then times the sine of 60.8. Right, that'll give the answer of the problem. I'll just round this maybe to 1 decimal. So let's say 722.1. And again, that is in square units. All right, so that's how you do that triangle formula. It's very simple. It holds for the side angle side case. Learn it in words. It's 1/2 the product of the two sides times the angle in between. All right, now we're going to move on to an application, this number 4, of that principle. So what we're going to do is we're going to find the area of this quadrilateral. And the way to do this, if you have a quadrilateral, any four-sided figure could be divided into two triangles. So I could either divide this way or I could divide this way. I'm just going to go ahead and draw a diagonal like that. And I'm going to call this A1 for the area of this triangle. And I'm going to call this A2 for the area of that triangle. So the way I'm going to compute this is I'm going to say the area of the total quadrilateral is going to be the area of this triangle plus the area of the second triangle. So all I really need to do is just compute each of these areas. So when I do A1, notice that A1, I have a side angle side case given, so I can compute the area of that triangle by the formula that we've been working with. So I just go 1/2 the product of the two sides, 4.1 feet, times 2.81 feet, times the sine of the included angle 85 degrees. That's how I'm going to do that. And then A2, I'm going to do this. For A2, I've got a side angle side case again, so I'm going to compute that like this. I'll say 1/2 times the product of the two sides, which are 2.94 feet and 4.80 feet. Then I'm going to multiply that by the sine of the included angle 72 degrees. Then I'll add those two things together. All right, so I'm going to go ahead and just do this on the calculator, each one. So A1, I'm going to put in 0.5 times 4.14 times 2.81 times the sine of 85. Okay, and then that will compute as approximately 5.8 square feet when I do that. So I just did 1/2 times the product of the two sides times the sine of the included angle 85. Okay, now I'll compute the next one. So I'll do 0.5. I'm going to use parentheses this time. And I'm going to go 2.94 times 4.80 and times, you can leave that time sign off, the sine of 72 degrees. And that will give an answer of approximately 6.7 square feet. Okay, so that's all we got to do to compute that with the calculator. Now to get the answer, I just go area 1, which was 5.8 square feet, plus 6.7 square feet. Then I can add those two things together. So 5.8 and 6.7, 8 and 7 is 5, carry the 1. That will be 12.5 square feet. Okay, and that's the answer. So you can take any type of a diagram, like a quadrilateral can be divided into three triangles. If you had a five-sided figure like a pentagon, you could divide that up into three triangles and so forth. All right, so that would be the final answer for finding the area. All right, now the next thing I'm going to go to is if you're given all three sides, we have a different formula that we can use that is called HURONS Formula, and it is credited for Huron of Alexandria. So I think I had put in your note handout a little thing about Huron. This is a picture of Huron. He lived right around 0 AD. Nobody knows for sure when he died, but we know he was a Greek mathematician and inventor of that time who lived around 0 AD. Okay, so it's kind of debated on when he lived. He did a lot of things, a lot of books. You can kind of read some of this if you're interested about Huron's life. And he's credited for doing several things that are kind of interesting on here. He invented, I always thought it was interesting, he invented the vending machine, a steam turbine, wind-powered organ. So he was considered to be the greatest inventor of antiquity, and he was also a mathematician. So he is credited for the development of this formula called HURONS Formula. So what you do on HURONS Formula, this goes with when you're given three sides of a triangle. So first of all, you compute you add the three sides and divide by 2. And then, to get the area, you do this formula with the square root in it. So HURONS Formula is real easy to remember, and it's also very easy to compute. So on this particular problem, you don't really have to draw a triangle diagram out on this, but I'm going to do that just to show you that you've been given all three sides of a triangle, and then we'll use HURONS Formula to compute this. The proof is a little challenging, so I'm not going to do the derivation of this. But basically, let's just say you have alpha, beta, and gamma, and then side A is given as 240, side B is given as 127, and side C is given as 320. So if you want to find the area of that triangle, HURONS Formula instructs you to do two things. First of all, you compute what is called S. And what we're going to do on that is S is just equal to the sum of the three sides and then divide by 2. So we're going to go ahead and use our calculator to help with that. So side A is 240, side B is 127, side C is 320, then you're going to divide that by 2. Okay, so when I do that, let's go ahead and take our calculator out and do that. So we got 240 plus 127 plus 320. Get that answer, so that's going to be 687, and then we're going to divide that by 2. Okay, so that will give 343.5. So that's step 1, is to compute that. Now when you do HURONS Formula, what you do is HURONS Formula just kind of takes up a lot of room on your paper, so you're going to do the area, and we're going to do this real big square root. So it goes like this. What you do is you take this value of S, and then you plug that in under the radical. Then what you do is you have 3 sets of parentheses. So what we do is we take the value of S, and we subtract it from the first side, 240. Then we go to the next parenthesis, and we do 343.5, and subtract the second side. And then we do 343.5, and then we subtract the third side. Okay, now this would be expected. You could do this on one step in your calculator like this. So I'm just going to put in square root, and then we have a parenthesis coming out, and we're going to have this whole thing under the radical. So I'm going to put 343.5, then a new parenthesis, and do 343.5 minus 240. Close the parenthesis, so you can let the calculator do all the work for you. Then the next parenthesis is 343.5 minus 127. Then a new parenthesis, we're going to put 343.5 minus the third side, which is 320. You want to be careful that you get everything put in. Then double the parentheses. So I have a parenthesis at the beginning and a parenthesis at the end. So I've got the S, and then S minus A times S minus B times S minus C, all under a radical, and then that will give the answer of the problem. So that area is approximately 13,449.2 square units. Okay, and that's a really big area because the sides are fairly big. So that's how you compute HURONS Formula. All right, so all I'm going to have you do, and then we're going to be finished up with this section because there's not much in this section, is compute these. So HURONS Formula, I'll let you work on number 7. I'll write the formula down for you. A is S times S minus A times S minus B times S minus C. And then S, the semi-perimeter it's called. What you're doing is A plus B plus C, and then divide that by 2. So I'm going to pause and let you finish up that problem. Okay, so let's see if we got this one computed okay. Now this time I'm not going to draw a diagram. You don't really have to. So S is just going to be the sum of the 3 sides, and then divide that by 2. So you want to go ahead and do this on the calculator. Okay, so I'll get this cleared and do that on the calculator for you. So 52.9 plus 65.4 plus 36.4. is going to give a value of 154.7. Then we're going to divide that by 2 on the calculator, which will give 77.35. So what we found is what we call the semi-perimeter, which is going to plug in right there. Right, now when we put this all together, we can do this in one step on the calculator. The area of the triangle is given by, got this big square root, so put in S, 77.35. Then draw out your 3 sets of parentheses. And then you put the semi-perimeter first in each parenthesis. And then you subtract each side. So side A is 52.9. Then do side B. Side B is 65.4. And then do side C, which is 36.4. Go to your calculator and do this in one step. All right, so I'm just going to put in square root, parenthesis, and then 77.35, the value of S, times parentheses 77.35, subtract the first side, 52.9. Okay, and then the next side is going to be 77.35, subtract the second side, 65.4. And then the last thing would be 77.35 and subtract the last side, 36.4. So you can see on my calculator I have S, S minus A, S minus B, S minus C. And then you can put that parenthesis to close. That closes the parenthesis on the parenthesis that's right by the square root. Press enter, and then it's all calculated for you. So we'll just round that off to 962 square units. Okay, and that's all there is to Huron's formula. So this section you're going to find is very simple, just working with 2 formulas, Huron's formula and the side angle side formula, like this. So you got side angle side, and then we have Huron's formula that does the side case. And that's all there is to this section. Should be pretty straightforward and shouldn't have too much trouble with it. You'll want to use your calculator to get everything calculated out. All right, so hopefully that'll help you to get everything under control with the area of the triangle.